Okay, I hope my voice is clear. Can someone just tell me in the chat if my voice is clear, everything is good? Yep, so that I can begin. Is everything good? Yeah, great. Thank you so much. Okay, so welcome everyone. I'm Kaiwan, and today my objective is to give you guys a head start into the Sec 3 and Sec 4 syllabus of EMAth. So I'll give a little introduction about myself. So let's begin. So my name is Kaiwan, as you can see from my video. I hope my video is on. Yep, it is. Okay. I'm the tutor, the upper sec math tutor. So I teach both EMath and AMath, and I've been teaching about 5 years now. And I primarily focus on group tuition. So I don't really take one-to-one students. Most of the time, I do teach in a group setting. That's where I teach. I'm more comfortable in my elements. And currently, right now, I'm still teaching around. So I have my Sec 4 classes next year, Sec 4 students, some classes there. And also, I do teach like in other centers as well. So today, I'm here to just give you guys a little introduction to the Sec 3 syllabus. So I believe majority that are here are all Sec 2s gearing up towards Sec 3. So today is just a little teaser as to what you can expect for the Sec 3 life and Sec 3 mathematics. Okay. So some background information about myself. Now, I'm from NTU. I'm currently still studying at NTU. I'm in my third year and I study mathematics. So yeah, I'm one of those weird people that study math. And my interest is in pure mathematics. So it's all of the proving, the understanding of how math works and why math works. And my interest is more on the topological side of things and the geometry side of things. So maybe in a way you can think of it as like the trigo chapters, the circle chapters for those that already know what's going on. So those are things that I love to study, and I'm here to share my knowledge with everyone. Okay. So what's today's agenda? So today is a very chill session. So it will not be like focusing so much on the content. Today, I just want to give you guys like a little introduction as to what the syllabus is going to be about. I believe some of your schools have already conducted this in school before you guys chose your streaming subjects. But I'm here to give you guys a little, like even deeper dive down into some of the topics and what to actually take note of. And also will give my little intake on what I feel is difficult, what I feel is easy, and how do you revise moving up to the O levels in 2 years' time. Okay, then also I will actually be covering a little bit into the new topic, which is the very first chapter. Now, this chapter, everyone has already covered the main chunk of it. It's just the last two sections, which is a little bit more challenging, which is Cap 4, upper sec. So that is where I'll be focusing my time on. Okay, so let me talk all the briefing first, then we shall begin on with the lesson. Also, just take note that at the very end, the last 15 minutes of the session, you'll be a Q&A. So if anyone has any questions for me, want to ask like anything, feel free to stay all the way to the end and you can just ask your questions there, okay? So let's start with the overview of the syllabus. So the syllabus from Sec 2 to Sec 3 math is actually it's pretty similar. It's just that there are new chapters that are being taught in upper sec because of the difficulty in them compared to lower sec. And also some of the topics, they will add on more and more content. So I'll give you guys an example. Like for example, let's talk about the graphing chapter here. So I hope you can see my annotations. So this graphing chapter here, although you have learned how to sketch a quadratic graph or a straight line graph in lower sec, you will learn what is a reciprocal odd, reciprocal even graph, or even what is a cubic graph. So there are extensions to what you have learned. Now, there are some topics that are pretty similar to what you have covered before, like for example, ratio proportion, percentage, maybe speed, equations, quadratic equations, trigo a little bit. I know some students do take angles, triangles, polygons. Now, all these chapters are from the lower sec syllabus. The rest are more of the upper sec content. So do not throw away your Sec 2 content, okay, because you do need this information in order to move on into Sec 3. So Sec 3 is just like layering on like a cake, okay? Now, some of the topics here are for Sec 4. Let me just share with you which are they. So vectors, set language and notation, and matrices. So because of the way Sec 4 is being run, usually by March to April, schools will finish the syllabus. So that's why they only keep the last 3 chapters for Sec 4. Now, the one topic to take note will be this. So later I will dive a little bit into like what I feel are the hardest topics for the math syllabus. Okay. So yeah. Oh yes. Okay. So another thing that I do that is a little bit different from other tutors is to actually split out the subjects into different cores. So I call this the algebra core, the geometry and measurement core, and the statistics core. So they are talking about different aspects of the mathematics syllabus. So if you take A math, then you will learn another 3 more types of mathematics. So it's all about like categorizing what you learn, and also it'll be easier for you when you do your revision. Okay, so let's carry on. Now, some of the hardest topics. So this is a page where I think is pretty important because these are the chapters that I personally feel is where students struggle. So I've been taking graduating classes for quite a while now, and I've seen my fair share of students where I know that they struggle there, especially vectors, which is this topic here, circles, and coordinate geometry. These 3 chapters here are more of the very, very deadly chapters because they are known to be slightly more challenging in nature and questions can vary in style. So do take note when you're learning these topics because it is very important to understand the concepts coming from them. And then when you apply into questions, there should not be any problem after that. So just take note that, yeah, do take note of these topics. Not to say that the other topics are not important, but these are especially important because you do need the foundations in order to score for these kind of questions. Now, the Sec 4 and Sec 3 syllabus is a really long content. Do take note that everything will be tested for O's. So you need to know every single nitty-gritty of the syllabus. Okay? Now, so revision. What do I recommend? Now, I know majority of you are still in your holiday mood, okay, waiting for Christmas next week. So don't really have the mood to study, which are totally fair, okay? But for mathematics, one very important thing about math is to practice. Now, practice makes perfect for any subject, especially mathematics. Why? Because you need the revision, you need the constant rigor of going through questions, doing and doing and doing, in order for you to go into the exam saying, oh, I recognize this question. I know how to do it. That is the main objective of practicing so much. Okay. Now, some things that I tell my students personally is to always look out for questions that look similar because their answering styles are exactly the same. It's just like science. You look out for keywords. In math, you look out for the same question style. And that's how I have actually designed my course, designed the syllabus in a way where it's all about identifying patterns and knowing how to answer when you see a certain pattern type. Okay, so for me personally, last time I take about maybe 1 hour to 2 hours a day to do math. Now I know not everyone loves math like me, so you may take priority in your other subjects. And also, if you're moving on into Sec 3, this is where you have like multiple sciences, triple science, your combined humans, you have a lot of subjects to tackle. So do plan out your time wisely. Have a calendar system where you say, okay, I'm going to spend maybe 8 p.m. to 9 p.m. to do math. Then after that, half an hour TikTok, something like that. Okay, at least give yourself some time to do math and always remember to practice. Now, if you have joined the channel, I don't know whether you have noticed, or maybe this is your first time in the channel. Something that I do for the channel is that I upload free questions every single month. So I will be doing that again this year. So starting from February onwards, I'll be uploading a document for both AMath and EMath where it will contain questions for practice. And this is completely free. The solutions will be provided at the end of the month. So if you want to check, you can check out with that. Okay. Now, some important tips about math, okay, it's very important to get your foundations right. So I don't know how is your Sec 1, Sec 2 math like. Maybe some of you are scoring A1s for them, or maybe some are failing really badly. Now, for those that are failing really badly, take this time during the December holiday to actually focus on your foundations because the upper sec math is actually tapping a lot onto your lower sec math. So it's not like you can throw them away and hope that you go into Sec 3 and, oh, I'm going to learn everything start from scratch again. No, you're going to fall very far behind if you actually do that. Now, for those that are getting A1s, now don't be complacent, okay, because lower sec math is chicken feed. Okay, personally, it is a cakewalk. When you go into upper sec, you're going to get your first hits of boom. It's going to be slightly more challenging. Okay, so you must get your foundations right. Don't get overconfident and remember to practice a lot. Okay, clarify your doubts early. So because this concept here or this tip here applies for all the subjects as well, because every subject layers. We don't want it to be a case where you struggle in topic 1, then you cannot understand topic 5, and then topic 5 will lead on to topic 6, topic 6 leads on to topic 7, and it drags on and on and on and on, and then once you reach the end you realize, wow, I'm screwed. Now you cannot do that. Start early and start clarifying your mistakes. Ask your teachers, why am I making this mistake, or what can I do to improve? Okay, this is important as well. And last one is to be consistent. So consistency is key. I believe everyone has heard this statement before. So being consistent is where you practice every day. So it becomes like a common nature. It's like how you can memorize the national anthem. Why is it everyone knows the national anthem by heart? Or why is it everyone knows the pledge by heart? It's because we say it every single day. If you read your notes every single day, it will go into memory. Okay, so be consistent in your studies for your O levels. Now, these are the exams and what the timeline is going to be like throughout the year for Sec 3 and Sec 4. So I'll share it with you now. I know majority is still holiday, so telling you guys this information may not be like very stressful. Okay, don't take it too seriously now. When you first step into school next year in January, okay, then that is where the real world starts. Okay, so there are exams all around the place. So CAs, MYE, you will start to learn topics by then. Just take note that by EOY, you will have completed about maybe 70 to 80% of the syllabus already. Then when you go into Sec 4, by this period, your CA1, you will have already completed all the way until matrices. Usually, they will leave vectors for the very end, because vectors is a very, very disgusting topic. It's very bad. So they usually keep like 1 full month to teach vectors. So just take note, it will actually speed up really quickly. So if you have the time during the holidays, do take the time to actually revise, read through the content a little bit. It will help you in the long run. Okay. Yep. So now this portion of this series that I'm doing right now is to share with you the little few things that I do for my students. So of course, let me share with you. This is everything that I prepare for my students. So like notes to questions to everything. So this is just to let everyone know what you will be getting if you were to join me and let me take you on the journey for mathematics. Sound like a roller coaster, but yeah, I'm bringing you on a journey to get your A1 for math. Okay, so there are some materials that I do. Number one will be lecture notes. So lecture notes, I'll create notes that is completely different from the textbook, and it's also not the same as assessment book. These are purely my own, handwritten on my own. So for all these notes, you will get it when I start the topic, and inside the notes actually contain example questions and the content that you need to know. So you can see the picture there, and you can also refer to the Dropbox materials. Inside contains some of the notes that I will be using. Now, the one in the Sec 3 set of notes is actually from my curated notes, which I'll share later what is it. So I didn't manage to finish writing the Sec 3 first topic yet. So unfortunately, I'm going to use my curated notes first for this lesson today. Okay, so but just take note that this is something that everyone will actually receive. Next is homework. So I believe in homework, and problem sets are questions that I will give you on a weekly basis. So problem sets is a university term, or we can just call it homework. Okay, so for problem sets, it's about 7 to 8 questions every single week, and they'll vary in multitude of topics. Now, because you're in Sec 2s going to Sec 3s, so I will choose those topics they have already covered in Sec 2s and to build upon them. It's for you to get to know the topics more and to give you guys more exposure to school questions and prelim questions as well. Now, I've been teaching for many, many years, for 5 years already. And I was a student myself, and I keep all my materials since when I was still a student. So that was like 2010. It's close to 11, 12 years worth of materials. And there are questions inside that are so good that I highlight myself, and I know, okay, these are questions that I need to go through with my students because they are important. Okay, just take note that this is what I will do every week, and don't need to worry, solutions will actually come along with them, and I'll show you in a while. Now, class assessments. So class assessments and class tests. This is something that I do on a weekly basis as well, because it's important to get everyone into the mindset of going for exams and to prepare for your questions. And how do you deal with like questions that are given to you on the spot? How do you recall your concepts? So this is something that I do for my physical classes and my online classes as well. So if you were to join me next week for the real lesson, then you will get to see what this is actually all about. Now, class test is something that I set for students in a bi-monthly to monthly basis, depending on your level. And the reason for class test is to get you guys ready for the exams. And I will go through and I'll give you guys statistics, I'll give an examiner report, I'll give everything that you need for your revision for this class test as well. Okay, next is solutions. So something that I pride on a lot, okay, and I feel that I do a good job as compared to many other people, is to write personal solutions. So all my answers are not copied off school. So I'm not using the school answer key. I'm writing them purely on my own. I hand solve the questions first, and then I post my answers online or post for everyone and give it to you guys. Now, all my answers are very guided. So as you can see, like I will tell you what is going on, why is it supposed to be done this way, such that if, let's say, you're in a very last minute crunch, you need to revise, you can always read the question, read through the solutions, and it will give you a guide as to how they're going to help you solve the question. Okay. Now, just a little caveat that I do for my students is about the submission of homework. Now, I don't chase students to do, but I do a one-to-one exchange. You give me your work, I give you the answer key. Okay, so this is something that I enforce everywhere, all over my students. Okay. Now, just last few things. Okay, these are the materials that you will be getting if you become my students. So you will get like school papers, homework, revision packages, the curated notes. So later I'll touch a little bit on what is that. I'll go through the O-level papers with you. I will cover what is the syllabus required that you need for your mid-years, end of years, and everything that you need for your exams. Okay. Now, so let's start right now, okay, officially with the lesson, and I'm going to cover a little bit on the problem set, which I have uploaded previously. And today I'll touch a little bit onto the first chapter, which is the numbers and the for operations chapter. Okay. So let me explain what is this problem set first. So inside, I think it's about 9 questions that I've chosen from my archives. I've uploaded them, but unfortunately today, due to the short time span, I'm unable to go through every single question because some of the questions are pretty long. So I've actually chosen 2 of the questions inside, and I'll actually be going through them. So this is just like a little demonstration of how I go through the questions, and it's also informative for everyone. Okay. Then afterwards, once I'm done with that, I will start on the new topic and go through a little bit onto the indices and set notation portions, the standard notation portion of the chapter. Okay. Okay, so let's begin. So this is the problem set. Now the Dropbox folder already contains this document there. So all my homework is designed this way with a cover page, the formula list that you will get, and all the questions that entails afterwards. Okay. So I'm going to choose 2 questions, one algebra and one standard solving question, and I'll just go through them and I'll write the solutions on my iPad. So give me a sec while I pull out the document. Now, don't need to worry. In case you're curious about how the other questions are being solved, I will also be providing the final solutions for all questions, and I'll drop it into the Dropbox after the lesson. Maybe you give me about 1 to 2 hours because I need to prepare for the Sec 4 session. So take a while, then the final answers will actually be uploaded there. Okay. So let me choose 2 questions. I want to do question 1 and question 5. So these are the 2 that I want to cover today. So question 1 will be a number pattern question, and question 5 will be the algebra, some interesting algebra question that I feel is pretty worthy to go through. Okay. So yeah. Now, if anyone has any questions with regards to my teaching, or let's say you cannot understand the concept that I've gone through, keep your questions to the very end at about 4:45. Then I'll start entertaining questions that you guys have. Okay. So let's begin with the first question. So I hope everyone can see the screen. I'll zoom in because it's a bit small. So give me a sec. Okay. And there we go. Okay, so let's go. This is the first question that I'll be covering today. So this is a Sec 2 Bukit Merah Secondary School question that I've modified a little bit, and now I'll be covering them. Okay. So the diagram below shows a sequence of tiling patterns formed by using small square tiles of length 1 centimeter. The table below shows some of the observations being made. You need to find the value of x. That's question 1. Draw the fourth figure, and so on and so forth. Now, this is a number pattern question. So number patterns is something that majority have already covered in school, and number patterns is actually one of the quote-unquote difficult topics of the syllabus. Now, why I say that is because a lot of people struggle in doing number patterns and cannot get out that particular end formula. So that is something that I want to help you guys with, and hope that it will make your number pattern journey in upper sec a lot smoother. Okay, so I'll actually write on a separate document. So later I'll upload this handwritten document as well. Okay, so let's go. So this is the question. So the question says that I need to find what is the value of x. So let's look at the pattern. There's a 3, there's a 5, there's a 7, there's an x. So obviously the answer is going to be 9. Okay, so for part A, so this is question 1. Part A, x is 9. Okay, we don't need any explanations. This is pretty straightforward, so we can just move on with that. Now, part B, the question is asking you to draw what is the fourth figure. So that is the figure right after here. So let me mark it out right here. So let's look at the pattern. We see that there's a tree-shaped L, then it's 5, then is 7. So obviously the last one is going to be 9. Okay, it's a pretty straightforward question, so nothing too difficult here. So let me flex my A1 art skills. Okay, clearly not A1 yet. And yeah, sorry. Yeah, okay, assuming that this is a beautiful diagram. Okay, there should be 4 on the bottom. So let's draw that. So 1, 2, oh, okay, so let me just check. 3, 4, 5, 1, 2, 3, 4, 5. Okay, this is the answer. Okay, sorry for the bad drawing. Hope this is clear enough. But C, okay, express y in terms of n. Okay, so that is where the formula thing starts. Okay, so y and n. So means I need to relate my figure number with my number of squares. So I'm going to use this method called the term number method. So I'm going to write it out properly. So T1, T2, T3, T4, Tn. And I know my numbers are 3, 5, 7, 9, unknown. Okay, so how to do? This is usually the question that most students will struggle in. So I'm going to introduce you this new formula, okay, that is not taught in O-level. Okay, funny enough, right, this particular formula is only introduced in A-levels, but it is really important and it's a really powerful formula because it can help to solve all kinds of questions that look like this. Now, this formula is called an AP, or arithmetic progression. So let me spell it out for you. Okay, so this is what we call an AP. So an arithmetic progression, AP. So what is the definition of an arithmetic progression? It's basically a sequence that looks like this, that has a common difference. So let me write this, common difference. Now, a common difference means that the interval between each of the numbers are the same. So I'll give you an example, 1, 2, 3, 4, 5. Okay, this is a AP because the difference between each number is 1. Same thing for 2, 4, 6, 8, 10. The difference is 2. 3, 5, 7, 9, 10, 11. The difference is 2. It's the same thing. Okay, and this is what we call an AP. Now, there's a specific formula for this, and this is Tn is equals to A plus n minus 1 times D. Okay, now there are many letters. Let me explain what these letters are. Now, A is your first term. So A is the very first number that appears in the sequence. So for this case here, it is 3. Okay. For D, this is what we call the common difference. Okay, so common, difference. Now, you need to take note that this common difference is a really important rule because it doesn't work for formulas that is like 1, 3, 8, 11, or numbers that are jumping off a bigger scale. It doesn't work for this particular sequence. This formula only works when the intervals between each number is actually the same. So like 2, 4, 6, 8, 10, 1, 3, 5, 7, 9. Now, a common question that I will receive is that, oh, then how do you solve those kind of questions? Now, unfortunately, there is no specific formula for those that have a like changing difference. But a good news for O levels is that about 90 to 95% of number pattern questions are always common different questions. Okay, so about 90 to 95%. Now, there's still that occasional 10% that is not, then those you need to actually observe the pattern to actually get the answer out. Okay, so let me demonstrate the working for this question now. So Tn, okay, is equals to 3, which is A, plus n minus 1 multiplied by 2. And the final answer is 2n minus 1. Ooh, plus 1, sorry. Okay, so it's 2n plus 1. Yeah, I hope this is clear. Okay, if anyone has any questions with regards to this AP formula, later at the very end, you can ask me. Next is part D. So for part D, oh, sorry, there's a part 2 there. Okay, so I need to derive a formula that shows the relationship between P and S. Okay, so let's look at it. So I have a 3. Let's write out the letters and numbers respectively. So this is S and P. Okay, this is 3, 5, 7, 9. And the other one is 8, 12, 16, and 20. So 8, 12, 16, and 20. Okay, so for this kind, because you're looking for a relationship between these two, you need to form like some mathematical equation between them and see. It must make sure that it works for every single line. Okay, so if you observe, if you take S and multiply by 2, you can actually add another 2, and you actually get all of them. Okay, so final answer will be P equals to 2S plus 2, or we can simplify it to 2S plus 1. Okay, this is how you form a relationship between the S and the P row. Okay, I think it's pretty straightforward as well. Next would be, this is D part 1. So move on to D part 2. So let me check, D part 2. Okay, D part 2. Hence, use this formula to find P if the perimeter of the figure when S is equals to 43. Okay, so for this kind, because you already have formed the relationship, so we know that when S equals to 43, I can do the substitution. So P equals to 2, 43 plus 1, which is 44. 44 times 2 is 48. 88, sorry, 88. Final answer. Okay, so if you realize, if you can't do part 1, then your part 2 will GGWP. Okay, part E. Oops, sorry. Ooh, hang on. Part E. Okay. Part E. Oh, okay, which is this one. Sorry, I think it's a coding error. Okay. Joseph claimed that the perimeter of 1 of the later figure is 147. Is his claim true? Explain your answer if it's true and disprove his claim with proper justifications if it's not true. Okay. So now the question states that this person claims that one of the figures is going to have a perimeter of 147. Okay, so let's test it out. So P is obviously 147. So let's check. 147 is equals to 2S plus 1. Okay, and we're going to solve for S. So let's solve for S. We take 147 divided by 2 minus 1. Okay, and the result is 72.5. Now, let's ask ourselves, let's check very carefully. 72.5. And what is the definition of S? Number of squares. Can you have half a square? In this case, no. Okay, if you realize that all of your numbers here are actually whole integers and they're positive integers, so 72.5 is actually not possible. So something I will write is this not a positive integer. So since s is not a positive integer, therefore Joseph is wrong. Okay. Now, just take note, these symbols here, don't need to know. Okay, it just basically means not a positive integer. Okay, and we're done. Simple question. Okay, so this is my handwritten version. I hope my handwriting is fine. Hope it's clean. Now I'll move on to the next question that I want to go through for today, which is question 5. Okay, I'll upload this handwritten version into the Dropbox later under this folder called handwritten notes in case you are interested in it. And then the typed up version of the solutions will actually be provided also. Give me about 1 hour, then I'll upload them. Okay, and every question will have all the answers and it's in a nice typed up PDF and whatsoever. Okay. Now, let's move on to question 5. So that is the next one that I'm interested in because I know 5 is challenging. Okay, so this is the question. So if 1 over m minus 1 over n is equals to 5, you need to find the numerical value for 3m plus 5mn minus 3n over m minus 3mn minus n. Okay, so this is also a Sec 2 question. So it may look a bit, okay, looks pretty easy. If your algebra is pretty strong, then good for you. But to some, this may actually be a little bit of a challenge. Okay, so that's why I decided to go through this today. SMSS is St. Mark's, so it's a St. Margaret Girls question. So let's go through. Okay, now all my questions, right, if I were to credit or I were to take it from a school prelim paper or EOY paper, I will always credit the school. So like, for example, Nanyang Girls High, St. Mark's. Okay, so it will just to make sure that everyone knows that this question is from the school. Now, let's go through. So for a new document, my formula is 1 over m minus 1 over n equals to 5. And I want you to find what is the value. So find what is 3m plus 5mn minus 3n divided by m minus 3mn minus n. Okay, now what's the reason why I chose this question is because it's pretty similar to what you will actually encounter in upper sec. So I think it's a good transition into that phase. Now, okay, it's a bit weird that you're given literally one equation with 2 unknowns and you need to find an expression and the number. Okay, so this is where you need to put on a little bit of your thinking cap and think about it, how you solve this. Now, usually if they give you an equation with a numerical value, you should always start from there. So let's start from here. 1 over m minus 1 over n equals to 5. So, okay, maybe I can group it into a single fraction. So n minus m over mn equals to 5. Okay, I'm reaching somewhere. Maybe n minus m equals to 5mn. Okay, and let's call this equation 1. Now, from this equation here, okay, now I see an mn, I see an n minus m. Is it possible for me to get these things out such that I can do maybe a substitution? I think it's possible, right? So let's do some grouping together. So 3m minus 3n plus 5mn, m minus n minus, 3mn. Okay, looks good. Now, maybe I can factorize the 3 on the top. So 3m minus n plus 5mn divided by m minus n minus 3mn. Okay, looks good. Now, I have an m minus n, but here is n minus m. Oh dear. Okay, it's a bit different because now it's like, for example, it's a minus b, but the equation given me is b minus a. Then how to settle this? Okay, there is a trick. Okay, is to take the negative on both sides. So you can introduce a minus sign to both sides of the equation, and you can get m minus n equals to negative 5mn. Okay, so this concept here, taking negative on both sides. Okay, so a little analogy that I give is that when you take the negative sign, you can actually rotate the two terms. So if it's, for example, an a minus b, if you put a minus sign in front, you're able to change it to b minus a. Okay, let me give you show you the working. A minus b is the same thing as the negative of b minus a. Now, if you don't believe me, let me prove it to you. Now, let's expand negative b plus a, which is the same thing as a minus b. Okay, so let's simplify this. So we now know that m minus n is equals to the negative of 5mn. So we can do the substitution, which is 3 negative 5mn plus 5mn divided by negative 5mn minus 3mn. Okay, very good. No funny business going on. Numerator is negative 10mn, negative 8mn. Final answer is 1 1/4. Okay. So you see, from one equation alone, we just do a simple substitution, and then the numerical value comes out. Okay. So it's not as difficult as it seems. So I hope this is clear. Okay, I'll pause a while. Okay, so let me do one more question. I think I have the time. Okay, so that I show a little range of topics. So the first one was a number pattern. This is an algebra. Maybe I'll do a geometry question. Maybe that will help. Let's do question 3, okay, which is the triangle question. So this is 1. This is question 5. And now let's do question 3. Okay, I think I'll be able to complete this question in the next 5 to 10 minutes. Then after that, I'll go on to the new topic. Okay, so let's look at this. Okay, same thing. This is from Bukit Merah Secondary School. So this is where the school is from. Question is from, sorry. In the figure, BCD is a straight line. It is given that AB equals to AC, BC equals to 8.2, AD equals to 11.6, ADC equals to 33, BAC equals to 66. And you need to find all of these things. Okay. So usually when you're given a diagram that looks like this, now sometimes questions will not label the angles for you or will not label the lines for you. They will always label the vertices for you. Sometimes they won't label the angles. Now, it is important that you label it on your own, and it will help you in your visualization as well. Now, just one little note that I think is important. Now, this line here, BCD is a straight line. Now, I know this is a really stupid statement to say, but actually this is a really important statement. Now, in upper sec or in mathematics in general, you cannot assume that a line is straight. Okay, let me explain that. Now, you cannot assume that a line that contains 3 points is a straight line, because it is possible for a line to look like this, where this is 179 degrees. It is entirely possible. Questions must state that a line is straight before you can assume anything. So this is important. Okay, and this is an important knowledge to take on for the geometry chapters in the syllabus. So I hope this is clear for this question here. Now, let's look for angle CAD, okay, which is right here. So CAD, I don't think it's a difficult angle to find. If you realize this is a triangle, so if you actually find this first thing, then you can take the properties of a triangle and actually find this. Okay, so pretty straightforward. Now, BAC, if you notice the notches here, they are equal. So this is an isosceles triangle. So properties of an isosceles triangle is that the two base angles are equal. So let's solve it. Okay, so part A, we are looking for, so one to find CAD. Okay, WTF is not whatever everyone is thinking, it's not that, it's 1 to find. Okay, so this is what I am looking for. Okay, just to clarify. So angle ABC, okay, it's the same thing as 180 degrees minus 66. Yep, divided by 2. Numerical answer is 57. Okay, and remember, for all angle questions, starting from now, must write reason. So angles in an isosceles triangle. Now, of course, I'm abusing notation here. Writing this is actually not allowed in the exams. You do need to spell out the words isosceles triangle and angle. Okay, but for me, because I'm teaching and I need to speed up, so therefore I'm using shorthand here. So every equal sign that you write must contain a reason, unless it's those kind of arbitrary ones, like for example, 57 minus 20. Those that attach with no reasons don't need to write. But for those, it's like 180 minus something, or 360 minus something, must write reason. Okay, and you will lose marks if you do not write a reason. So please be careful. Angle CAD, now we can find. Okay, we have all the 4 angles in the triangle. So we have this, we have this, we have this. This is the unknown. So let's solve. Okay. Sorry, hang on. Yeah. Okay. So CAD is equals to 180 degrees minus 33 minus 66 minus 57. Sorry, 57. Sorry, hang on. My pencil is acting up. Okay. Yeah, there we go. 57. Answer is 24. Angles in a triangle. Okay, and this is the numerical answer. Next will be part B. So let's take a look at that. Part B asks you to find AC, which is this line right here. Okay, so how do you find? Okay, so let's look around and see what you can do. Okay, let's look at this isosceles triangle. I'm going to draw this isosceles triangle on my rough paper here. So isosceles. This is, sorry, let me just check the dimensions. This is A, this is B, this is C. We know that the sides are all equal in length, so this is 66. Now, a property that we can actually use is to split this triangle straight down the center. And a unique thing about an isosceles triangle is that if you draw a line going straight down like this will actually cut at a 90 degree, or what we call the perpendicular bisector of BC. So hence, we have formed a 90-degree triangle. So for this angle here, we know that this is 66 divided by 2, which is 33. This length here is unknown, and we know this. Remember, I said this is a perpendicular bisector, so it cuts the line exactly in half. So this length here is equals to this length. So that is actually 8.2 divided by 2, which is 4.1. Okay, so we have a right triangle now, and this is trigo. So we have the opposite side of the triangle, and we have the hypotenuse. So tuakaso. So opposite is the so sine. Okay, so we can use that. So yep, correct. SOH. So sine of 33 degrees. Let me write meter. Read. Sine 33 degrees is equals to 4.1 divided by AC, which we can find AC is the same thing as 41.7927921. Final numerical answer is 7.53 cm. Okay. Last one will be part C, okay, before we wrap this up, which is CD, which is this length right here. Okay, so this is a 3-mark question. So let's look around and see what we can do. Okay, we know that this angle here is 24. Okay, now what do you notice about angle DAB? DAB is actually 66 plus 24. which is actually 90. Okay, so you have actually found another right triangle in the question. So let's draw it now. This is D, this is A, and this is B, 90 degrees. So we need to still state that, let's state it down first. DAB is 90. Okay. So let's fill up some information. So we know that CD is something like right here. So this is the length that we're interested in. And we know that this is 33, or this is 57. Okay, and we have some of the lengths. We know that this length here is 11.6. Okay, so we can actually find. We do know this as well. So we have a right triangle, so we can use Pythagoras theorem to solve. So by Pythagoras theorem, okay, by Pythagoras theorem, we have AD squared plus AB squared equals to BD squared. So AD squared is 11.6 squared plus, now AB, take note that this is part of the isosceles triangle. So AB is actually part B's answer. Now I'm going to do something a little bit unconventional. 4.1 divided by the sine of 33. Now the reason I'm writing it this way, instead of the 7.53 or the 7.527921, is because I want to prevent rounding error. So something I'm doing is that I want to always keep the exact form if possible. This is so that when you type into the calculator, you will always get the answer that is the most exact possible. Now, for this particular one, it's a very simple fraction to write, so I can just write that as shown. Okay. So BD squared, let's write it down. We know that BD is made up of BC and CD. So this is 8.2 plus CD, holding square. So right now, we can happily solve the equation and we're done. So let's write it out. CD is the same thing as the root of 11.6 square plus 4.1 over the sine 33 squared outside minus 8.2. Okay, and since we are square rooting, just take note we are taking the positive and negative values, but obviously we want the positive value, so we don't need to do anything here. This is 5.628579. Final numerical answer is 5.63 cm. Okay, so just take note that this is the exact form. Now, of course, I'm weird, so I use the exact form. And exact form is something that I preach to my students to use. Now, of course, there are some people that don't want to do it because it's very long. You need to keep on writing it. And writing decimals is a lot easier. Please take note that you are not allowed to use this answer. You cannot use 7.53 because it's not enough significant figures. You need to use something that has at least 5 to 6. That is the bare minimum. That's why for me, personally, I always write the fraction. And for all my answer keys and solutions will always contain the exact form. Okay, so this is to prevent for myself from making any careless mistake on rounding error, and also to prevent myself from like writing too many decimals, you type wrongly into the calculator and then you make a mistake. Okay, and we're done. So these are the questions that I wanted to go through today. And yeah, this is the end of the problem set portion. Now, the remaining questions here, it's not they are not important, it's that I will not be going through because of time constraints. So what I will do is that I will upload the solutions for all of the remaining questions, including the 3 that I've just gone through today, into the Dropbox link. It's not there yet. Give me about maybe tonight after the Sec 4 session, then I'll upload everything together. The link will be up.
Some admin stuff. So the
Sorry. Okay, sorry about that. Don't know who that was that. Okay, but yeah, let me carry on again. So I will upload later. Okay, so just remember that the link will up before. Sorry, the link will be up for about maybe 7 days, and then maybe we'll take it down after that. Okay, so right now, after this problem set, let's go into the notes. Okay, so this is the notes section and how I'll actually be teaching my classes for the topics. Okay. Save untitled. Okay, so this is the first chapter, which is the numbers and the four operations portion of the syllabus. So this is chapter 1 of the algebra topics. So let's give a little go through. Now, these notes here are not specifically my lecture notes. So they are in another format. So this set of notes that you're seeing right here are actually from the curated notes. So curated notes is a batch of notes that I sell, and same for all the other overmarked tutors, where it's like a guidebook that contains example questions and also contains the content that you need for your revision for your O's. Now you can use this book at whatever level, so Set 3 or Set 4, because all the content there are exactly the same. Okay, but the difference between my curated and my lecture is that my lecture will contain more examples because I have a page count. I cannot hit too many pages on my curated. So all the other important examples will be in my lecture notes. Okay, but for today, due to time constraint, I couldn't finish the lecture notes. So I'm going to use the curated notes and show you guys what this set of notes are actually. Okay. Now, let's go. Okay, so this is the first chapter. So I will actually be covering a little bit about the old Sec 2 content and also be covering the new Sec 3 content as well. So the beginning, maybe the first like 5 minutes, let me recap the very easy portions of the chapter. Then I'll go a little bit into indices. Okay, so the first section is all about numbers. So numbers is the basic foundation for mathematics and what we need for math essentially. Okay, so we know that there are odd numbers and obviously there are even numbers as well. These are the two main classes of numbers. Now, a term that we use is called the word parity. So it's either positive or negative. So this one I think everyone already knows. Now, there are many classes of numbers out there. So it's like natural, integers, primes, real, rational, and irrational. So at this stage in Upper Sec, you do need to know the differences between the names because there are questions out there where they ask you, okay, list me a rational number or identify to me which of the following is prime, which of the following is a natural number. So you need to know the differences between them. And like, for example, natural excludes 0. Integers include 0. Okay, and maybe like prime is excluding 0 and 1. It's only numbers that are divisible by 1 in itself. So these are examples that you need to know. And there are questions out there where they will ask you specifically what they are. So that's why they're here. Okay, now these class of numbers are not specifically only this. There are actually many more. There's actually complex numbers. There's actually a field. There are many things, but this is the scope of the O-level syllabus. Okay, just take note that the definition of a rational number is a number that you can make into a fraction. So example will be like 2 over 1 or maybe 1 3 over 7. You can see the examples given there. And the difference between irrational means cannot make into a fraction. So this means you type into your calculator, it's automatically going to be a long string of decimals. Okay, good. So these are the examples of work. These are the work examples that I provide in the notes, so you can look through. So this is a good revision to tell you what is important, like what is an integer, what is a rational number, and there are questions like this in the O levels and in Upper Sec as well. Okay, so this one I will skip through, so they're pretty easy. Next, the four operations. So I think this one, if everyone's in secondary school, everyone already knows plus, minus, times, divide. So this one, nothing too much that I want to talk about. So just remember the order of operation, a BODMAS if you're using this rule. So brackets, operations, division, multiplication, addition, and subtraction. Okay. Now there is this controversial question, the 8 minus 2 times 3 plus something. Yeah. Okay, just remember that you need to use the BODMAS rule in order to solve out for math. So it's the same thing for algebra, it's the same thing for numbers. Now, why is this important? Because there is a specific type of questions where they always ask you like, oh, they give you some fractions and they say, without the use of the calculator, find this. Without the use of the calculator, find this. Okay, so you need to take note of that as well. Now, prefixes. Okay, so this is where things get important. So you need to know this. This is a list to memorize. So must start to drill this into your head because you do need to know what is a pico, what is nano, micro, milli, and whatsoever. The reason why is because there are questions out there where they give you like this. Okay, if you look at example A1.2.1, the question says there 6.6 microseconds. And they never tell you that micro is 10 power minus 6. You need to know yourself that micro is 10 power minus 6. Okay, so this list is an important list to memorize, especially both the positive side and the negative power side for prefixes. Okay. Questions, a lot of questions will come in this area, so you do need to know, and this links on to standard form as well, which is the new portion of the syllabus. Okay, so this one don't need to go through, it's too simple. So this is an example of a question that I was talking about. Showing your working clearly without the use of a calculator, need to evaluate the following. Excuse me. So what is the definition of without the use of a calculator? Now, please don't be a gundu, okay? It doesn't mean you cannot use. When they state there without the use of a calculator, it just means I want working. Okay, so I'll write here for you, one working. Okay, so all of the working must be shown. So as you can see here, I know that we can all just type this whole thing into the calculator and you'll spit out the answer for me. But the question once working is to understand the concepts of using the plus, minus, the brackets, and whatsoever. So every simple numerical step needs to be shown during the exams. So just remember this, okay? That without the use of the calculator, it doesn't mean the examiners are going to walk around and check which question you are on and make sure you don't use. No, it doesn't work that way. Okay, it just means that every single step must have a working attached to it. Okay? So prime factorization. So this is the next chunk. I think this one already everyone knows. So I'll just do a short recap on what this is. So you need to know the difference between the factors and multiples. So LCM and HCF, you need to know what they are and what the differences are, because there are many questions on them. Like questions will give you two numbers, ask you for the HCF, two numbers, ask you to find what is the LCM. Okay, there is a specific way to memorize what is an HCF and what is an LCM. So let me demonstrate. So for HCF, okay, we always take all the powers. We are going to take all the primes that are common. Okay, and we're going to take the lowest power. For LCM, okay, we're going to take all possible primes, okay, and the highest power. Okay, this is the difference between HCF and LCM. So for HCF, like for example, if the number is like 2 squared times 3, okay, maybe I'll write it down. So if it's like 2 squared times 3 times 5 squared, and the other one is maybe 2 cubed times 3 times 7. Okay, what is the HCF of this number? It's 2 squared times 3. Okay, so HCF is 2 squared times 3. The reason why is because I'm going to choose all the primes that are common. So in this case here is the 2 and the 3. And I want to choose the lowest possible power, which is 2. Okay, we do not want to include the 5 and the 7 in because that is for LCM. So let's write the LCM. So LCM for this case will be 2, 3, 5, and 7, and the highest possible power. So 2 cubed, 3, 5 square, and single 7. Okay, and these are all the values. Okay, so this is the main difference between HCF and LCM. Okay. Okay, apologies if my handwriting is a bit trash. Yeah. Okay, so this is what we're looking for. So I hope this is clear. The main difference between HCF and LCM. Now, the few questions after this will actually demonstrate what is the main difference between HCF and LCM and how to explain such questions. Okay. Okay, so yep, give you an example. So if you see question part A, okay, so the question says that you need to look for the smallest integer m such that 630m is a perfect square. Okay. So 630m is a perfect square. So what is the definition of a perfect square? So let me write it out. Perfect square means powers multiple of 2. Okay, so all the powers must be multiples of 2. So give you an example. Okay, 4. Why is it a perfect square? Because 2 square, maybe 25, 5 square. Okay, as long as your powers are all multiples of 2, we know that, okay, this number is a perfect square. So how do you make this a perfect square? You just need to multiply the numbers in such that you can get a perfect square. If you notice the 3 there, okay, this is already squared, so don't need to do anything about it. Okay. Yep. So this one done. Can move on. Okay. This one don't need. Okay. Next is ordering and relation symbol. So this one is also something that majority have learned before, but you may not have encountered these kind of questions before. So I want to show you guys what I mean. Now, ordering and relation symbols are your inequality symbols. So it's like your equal, less than, greater than, less than equals to, and greater than equals to. Now, this is not the chapter for inequalities, but there is a specific question type that we need to know, which is the next page. Okay. Yes, which is this concept here. So we need to know the different types of expressions involving relation symbols. So for example, the question will ask you, okay, given that x can be arranged between something to something, y can be arranged between something to something, find for me what is the biggest possible value of x plus 3, or what's the biggest possible value of x plus y, or what's the smallest possible value. We need to know the numerical combinations and how to actually get out the maximum or minimum of these numbers. Now, there are many tricks in this question. So these tricks, I mean, as in not tricks for you, but tricks to trick you. So there are many questions like this, like involving 0 or involving the negative numbers. These kind of questions are tricky, so please be careful. Okay, let me give you a demonstration right here. Okay, so if you look at 1 part A, the question is the inequality, -1 to 8 and 2 to 10 for x and y. What is the smallest possible value for x plus y? Now, of course, this is simple. We just want to find what is the smallest. So we're going to choose x to be the minimum and y to be the minimum. Okay, so answers 1. This is basic. But sometimes when we are dealing with squared numbers, this is where you need to be a little bit more careful. So squared numbers, right? If you want to find the smallest possible value, you need to remember that squaring a negative number will become positive. Okay? So this one must be very careful. Squaring a negative number will become positive. So if let's say the smallest possible number is -1, but you square it becomes 1. Oh no, that is not correct. Whenever we are dealing with squared numbers, the smallest will always be 0, okay, for smallest. Whenever there is a negative portion, the smallest possible will always be 0, and there's no two ways about it. Okay, so just take note of that. Okay, so the little explanation is right here. Okay, so do note that even though x min should be -1, we want x min squared, which is -1 squared, which is positive. If you want +1, that's not right, because we want a smaller value, which is 0. So remember that if you can square negative numbers, always take 0. Okay, common mistake. Okay, approximation and estimation. Now, this one is also something that everyone knows, so I'm not going to go through. So it's about how do you round and how do you estimate something. There are a few question types to memorize here or to know. So this one, we can go through it next time. Okay. And yeah, okay, now we go on into the topics that is a little bit more to the Sec 3, Sec 4 stuff, okay, which is standard form and indices. So I start off with the easier one, which is standard form. So standard form looks like this. So you know how sometimes numbers can be really big or really small? Now in physics, like for example, if you want to find what is the smallest possible atom, okay, what's the size of an atom? It's going to be something times 10 to the power of minus something. I cannot remember because I haven't taken chem in so many years. Or for example, what is Avogadro's constant? 6 point something times 10 to the power of 23. Now, why do we have this kind of notations? It's because we cannot write so many zeros. It's not physically possible. And our calculators cannot handle it. Okay, our Casio or the scientific calculator that we have cannot go so many zeros on the negative side as well. That's why we have this specific notation. Okay, so what does it mean? Okay, it basically means you have a number here, A, okay, which I'll tell you some conditions about later, times 10 to the power of something. So give you a demonstration. What is 100? 1 times 10 to the power of 2. Okay, because the power 2 there will tell you how many zeros you're going to actually add on to this 1. Okay, maybe for 1000, 1 times 10 to the power of 3. How about 0.1? Okay, since you're moving backwards, the decimal point, this is 1 times 10 to the power of minus 1. Okay, so we are moving backwards. So if you have a decimal, the power of n there will be negative, but if it's a positive number, it will be a positive digit. So it really depends on which direction of the number line we are actually looking at. Okay. Now, this is where this very important condition comes in, which is this line here. Here, I'll highlight in purple. I hope everyone can see. This is something that many students will make mistakes at and will 100% forget in exams. Okay, is that the condition for the value of A must be between the numbers 1 to 10. This is a standard notation throughout everywhere in the world, and everyone follows this. So it is mathematically incorrect to write 0.1 times 10 to the power of 2. This is wrong. You cannot write it this way because the number in front here must be a number between 1 to 10. Okay, now it can be a decimal point, it can be anything, but it must always fall between this range. It cannot be anything else. Okay, and also standard form is another way to help simplify numbers. Sometimes if you have if you're dealing with like millions of dollars in the future or in your questions, if you're not careful, you're going to miss out 1 0, and then you're going to type into your calculator wrongly, you're going to get the question wrong. Okay, so if you look at this simple question here, okay, you need to state the values of m. So the 9 and the 4. So if you take note, the 9 is at the ones place. So obviously it's 9. Okay. Sorry, this m should be 0. Okay. And the value of n here should be -2 because we are looking at 0.04. Okay. So this is 4 times 10 to the power of -2. Now, when your numbers are really simple, you can actually check it with a calculator. So if you check 9 times 10 to the power of 0, it's actually 9. Okay, and 4 times 10 to the power of -2 is actually 0.04. Okay, so this is a pretty basic question. Now, there are many other questions out there that contains standard form. So take note that this is the very first topic for EMAth, and it's an important concept because it's used all over the places, even in your sciences. So you need to know the manipulation well, you need to know how to deal with all of these kind of numbers. Okay, so yeah. And a good thing is that the calculator actually helps you with it. So if you key it in a standard form, your answers most of the time, if it's within like a really huge range, will be in the standard form. Okay. Now, okay, we come to my favorite portion of the chapter. So this is the very end of this chapter. And this is usually the portion where I will spend the most time on. Okay, but due to time constraint, I will spend maybe about 5 to 10 minutes here, and I explain as much as I can at this portion here. Now, in this, few years ago, maybe I would say when I was like 21, 22, or maybe like 2-3 years ago, before the change in the AMAth syllabus, indices used to be in AMAth. Okay, and it's tied on together with sets. But I don't know who in SCAB thought that this was easy. Okay, arguably it is, and they threw it into EMAth. Okay. Now, indices is a topic where it's either you get it or you don't, or it's whether your algebra is strong or not. It's a really algebra heavy concept portion. Okay, it deals with all of these laws. So these are the 9 laws that you need to memorize for exams, and some of the laws is actually pretty straightforward that we all already know. Okay, so I'll give you an example. This is something that we all know. Anything to the power of 0 is 1. So 2 to the power of 0 is 1. 3 to the power of 0 is 1. This is something simple. Having a negative power is literally taking like a fraction. So a to the power of minus 1 is 1 over a. Okay, a to the power of minus 2 is the same thing as 1 over a squared. So all this is more of like practice, and then once you keep on doing, it becomes second nature. You must remember that whenever you're moving something from a denominator up into the numerator, it becomes negative. So a to the power of minus 3. You can always check with your calculator to make sure that you're not making any mistakes. Okay, this is for the last two. Now, the radicals one, let's keep it for the end because this is something new. So later. Now, for the same base and same power. Okay, number 1 and number 4. These are two that a lot of people like to confuse, and very sad because if you confuse these two during exams, you will unfortunately get the question wrong. Okay, now when you have a number like 2 to the power of 2 times 2 to the power of 3, the powers are actually adding up. Now I know it's a bit weird, why is it adding up? But it's actually the fact lah. Okay, whenever we have the same base, which is like this, the values of a are the same, the powers are always added together. When they're in a fraction form like this, it is a minus sign. Okay, so these are ways that you need to know how to manipulate your equations. So there will be like questions like, okay, I give you a demonstration. So g squared, sorry, yeah, technical difficulty. Yep, okay. So give you an example. So maybe g squared over f cubed h squared multiplied by h squared over, or h cubed over g squared f squared. Okay, so when you have something like this, you need to know how to deal with it. How do you combine both of the fractions together? When you have the same bases like the f's in the denominators here, you're going to add the powers together. Okay, this is just memory work. Now, this is one that is also confusing as well. Okay, a lot of people confuse these two. A to the power of m to the power of n. So like for example, 2 square square. Okay, 2 square square is 16, which is 2 power 4. Okay, I know it's a bit weird, right? Okay, a way that I use to memorize between number 1 and number 3 is to sub in value. And trust me, this is something I do even at this stage because sometimes I will forget. Okay, there are too many formulas to remember, so no choice, I will use this way to memorize. Let me show you. I will key into my head. Okay, not key into my head, but think in my head. Okay, a2 to the, okay, maybe I'll use 2. 2 to the power of 2 times 2 to the power of 3. What value is it? Okay, you should actually get 2 power of 5. But if you do 2 square cubed, it's not. It's 2 power 6. Okay, so when I actually type this into the calculator, oh, okay, I automatically tell myself, okay, it's power 5. So I know that it's just the addition whenever you have the same base. Okay, when you have powers that are powering like this, they are a multiplication of each other. Now, this is a common mistake that all students starts off for indices will make one. Okay, same thing for fractions. Okay, you can always take it out. So for example, if it's like a over b whole thing squared, it's the same thing as squaring the numerator and squaring the denominator. Okay, so this is the first 6 laws. The last 2 is at the bottom here. Okay, so these are called radicals, or we call surds. So this one is just understanding and knowing what they are. So it's memory work again. A to the power of 1 over n is the same thing as root of n. Okay, or something that is more conventional will be a power half. So half is square root. So this is a way that we get rid of a square root. So taking that square root, right? Like how do we change that square root out into a fraction that looks like this will help you solve questions. And this is also the reason why when you square a square root, you will get back the original term. Let me demonstrate now. Why is it that we say the square root of a squared will become a? Why? Simple. A to the power of half squared. Now remember what I said earlier? Okay, when you have a same base a, the powers are multiplied. So a half times 2, 1, no? So it's A. This is the reason why. Okay. Now, just take note that this is just a variation of the radical formula. So if you have a m or numerical value on the top, then your inside value will actually be Howard as well. So if, for example, it's 2 to the power of 2 over 3, it's the same thing as the root of 2 squared. Okay, so all of this is really just practice, practice, and practice. There are many questions out there that will actually help you with it. Okay. Now, I just want to address this common mistake here. Now, a lot of people think this is true, and this is rubbish. Okay. A to the power of m plus b to the power of m. A lot of people think it's a to the plus b to the power of m. Now, this is 100% rubbish. It's not true. I've proven it below here. 1 cube plus 2 cube is 9. 1 plus 2 cube is 27. Okay, there are two completely different things. It's the same thing as a plus b squared. It's not the same thing as a squared plus b squared. You can think of it in the same way, except in the indices form. Okay. Now, there are just many examples here, so I don't want to go too much into detail. Okay, but this is an example of a question where you will actually learn like, okay, division, okay, you need to flip the fraction, then you combine everything together, and then you can solve the question. Okay, so this is all about practicing and all about knowing how to do. So there are many questions out there that we can practice and can learn from. Okay. Yeah, the rest are just example questions, so don't really want to talk too much about it. And yeah, okay. So this is just a really short summary of the chapter. And to be honest, most schools will finish this chapter within 1 to 2 weeks in school. Okay, so it's a super easy introduction chapter. But do take note, the indices always comes out for O's. Okay, and it's always like a 2-3 mark question that will come out. And if your algebra is not strong, please focus on this a lot. Go and work on your manipulation, work on your fractions, make sure that you don't fall behind for this particular portion. Because if you do, you are going to throw away like 2 to 3 bucks. That's really, really not worth it. Okay, so yeah, I'll leave you guys with this. Okay, so this is just a sample of my curated notes. Okay, and all the examples that will be inside. So unfortunately, like I mentioned previously, I was unable to prepare the lecture notes for this chapter. Okay, but it will look something like this, but it will contain like questions and spaces for you guys to solve and whatsoever. Okay, and I'm done for the lecture portion of this session. Okay, so go back to my slides. So yeah, I've completed the problem set. I've completed the topic. Now I'll not be going through set notation and language because that is for my Sec 4 session later. Okay, and yes, now to be honest, that's all I have. Okay, I'll take questions now. So if anyone has any questions with regards to and you want to ask me anything, now is the best time to ask in terms of like math, or you want to ask me like any general questions, you can take the time to ask. Just type into the chat, or if you want, you can unmute yourself. Now, before we actually cut off today's session, I just want to tell you guys about the trial session that's happening next week. So there is a difference between the head start and the trial. So this head start is just like, oh, a very chill session, just like a little introduction into the chapter. But my trial session next week on the 20th, this will be an official full lesson. So it'll be 2 hours and it'll be from 4:30 p.m. to 6:30 p.m. and it'll be online on Zoom again. Now, the reason for this, like why we do it this way is so that advertise to everyone and also to get you guys to know about our group tuition that is going on. Now, I don't have any students for Sec 3 at the moment, so I'm looking to open a class and I'm open to starting like maybe group of 3, group of 4, group of 5, or however number of people wants to sign up. Okay. So just take note that there's a free trial lesson. So there's two directions you can take. You can either go for straight away sign up with me and you'll automatically become my student. Or if you like, you can come for the free trial lesson where I will go even more into detail of whatever I've covered today. And I'll also show you the curated notes and everything. Okay, so the session will be next week on Monday, 4:30 to 6:30. The QR code is there, so you can sign up on the QR code. Then I will contact you within the next 1 to 2 working days. Okay. Now, the A-Math session is actually tomorrow. So if you're interested also, you can come down for the A-Math trial session. That will be next week. And the Head Start program will obviously be tomorrow. Okay, just take note that if you sign up for both A and E, there's a 10% discount that we offer because you're taught by me, and I think it's fair that we can give a 10% for everyone. Okay, so yeah, the last QR code at the bottom there is for the curated notes. So if you see the notes that I was referring to just now, those are the notes that you can actually purchase. And there are also other subjects notes that you can go there and see. So you can go and browse and go and check on the website as to what subjects you're interested in, and the tutors can reach out to you if you're purchasing the notes. Okay. Now, I'm done officially for today. So do sign up if you're interested for the trial lesson. And also the notes, if you're interested to getting a copy of the notes, do send an order in and make the purchase. If not, that's all for today. I will end the recording here. If anyone has any questions, I will stay for questions. Okay, bye-bye.